Hello everyone, welcome to my new programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is longest string chain. So you are given an array of words, where each word consists of lower English letters. Word A is said to be a predecessor of word B if only we can insert exactly one letter anywhere in word A and without changing the order of the other characters to make it equal to word B. For example, if your word is like this, ABCD, then its predecessor can be ABC, or you can say ACD, or you can say BCD. Basically, in all these strings, one letter can be inserted without changing the order of other characters, and it will make that this string equal to this string. This is A and this is B. So similarly for this also, B can be inserted, A can be inserted. So I hope you are able to understand. The problem further states that, for example, if ABC is the predecessor, B, AC of this particular string, and while CBA is not the predecessor of BCAD. So what you have to do is, a word chain is a sequence of, then it's further explained something called word chain. A word chain is a sequence of words where k is greater than equal to 1. So k words should be there, at least one word should be there, where word 1 is the predecessor of word 2 and word 2 is the predecessor of word 3, so on. So a word chain will be like this: W1, W2, W3, W4, up to, let's say, Wn of word chain of length n should be greater than equal to 1. So this will be the predecessor of this string. Now similarly, this will be the predecessor of this string. Now similarly, this will be the predecessor of this string, and so on. So it will be a word chain. So you have to return the longest possible word chain with the words chosen from the given list of words. So what will be the length of largest value of n here? Length of the word chain. What will be its largest value? So if you go on a brute force way, then what you can do is, let's say, let's have a look at the constraints first before considering the solution. So the words array will be of 10 raised to power, size of words array will be of 10 raised to power 3, order of 10 raised to power 3, and size of a word can be order of 16. So words, it is mentioned that only lower English letters are being used for constructing words. So let's say you consider a single word of maximum length possible. Let's say 16 length word is considered. 16 length word. Now, what can be the possible predecessors of this word? Possible predecessors. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the approach. So a number of possible predecessors. So for by deleting, since it's mentioned that predecessor and a successor will differentiate will have a difference of only one word, exactly one letter it's mentioned. By deleting every character, you will be generating a possible predecessor. And keeping rest, you will generate predecessor. So overall, string of length 16, let's say, can have maximum 16 possible predecessors. Given word. And there are n words in the array. Words array is of size n, which is of order 10 raised to power this 3. So how many number of combinations of chain can be there? Word chains. Let me quickly take another slide. How many number of possible word chains can be there? To take a loose upper bound, it will be not exactly, but it will be close to that, just a greater value. It can be 16 into 16 into 16, and so on. It will continue till size of words array. Then, which is 10 raised to power 3 of order 10 raised to power 3. So something like this will go on. So it will be it will be a loose upper bound, order of 16 power 10 raised to power 3. Something like this. And it will be 2 raised to power 4 10 raised to power 3, which will be 4 into 10 raised to power 3. So a loose upper bound, you can give this much number of operations will be required for your solution. Approximately number of operations required to generate all possible chains. So this particular will a number of operations is very much greater than 10 raised to power 8 operation limit. Basically, this is the limit for number of operations that your program can do in can have in 1 second. So if the number of operations of your program exceeds this limit or become equal to this particular limit, then you may get a yearly time limit exceeded, and your solution will not be accepted. So we have to optimize this particular solution. Now let's say while we were checking for the predecessors of a word, what you can do is, let's say word is there, let's call it X. So from all the predecessors, how could you have landed on X while forming a chain? You basically all the predecessors, from all the predecessors you can come to X. These are all the predecessors, all predecessors of X. While you are forming a chain, let's say you are forming chain A, B, C, D, and let's say D is a predecessor of X, you can come to X. Now let's say there is another chain X1, X2, X3, and X3 is a predecessor of X, then also you can come to X. So these are these will be the predecessors from which you can uh, end up at X. So for each value of X, and similarly, if you consider two separate chains, let these be two separate chains, chain 1 and chain 2. Now, contributions of X will be calculated more than once. Calculations for word X will be done more than once. Also, what will be the length of this particular chain will highly depend upon what will be the length of the chain starting from X till the very end. I hope you are able to understand. So you are clearly able to see that solution of bigger problem depends upon solution of smaller problem. Basically, by these two observations, let's call this number 2, and the previous one that we had calculating X for doing calculation for word X more than once, let's call this number 1. So this particular condition or property is called overlapping subproblems. Those of you who are new to this particular property, I will be providing a link for it. So you need not to worry. Our link of article will be provided. You can explore that article. And similarly, this property's name is optimal substructure. Basically, the solution of a bigger problem can be obtained by solving smaller problems and combining their solution to make the solution of bigger problem. So it can be visualized something like this: big solution, small solutions. You can combine them and then form this. So link for this particular property will also be provided to you. And when these two properties satisfies uh, this, in a problem, that makes a problem to be a worthy candidate of applying dynamic programming. So those of you who are new to this concept, I will be providing a link for this one also. Link of an article explaining dynamic programming. What dynamic programming is. Basically, it is nothing but we are storing the result of this particular X, so that we need not have to do calculation for it again and again. For every state here is nothing but a word. For every state, every word, or you can say a state, we will store its result. Now you may ask what the result can be. Length of chain starting from this. Maximum length of chain starting from X. For everybody you will be storing this particular thing. Then what you can do is when you will encounter this particular problem again and again, you can use just your stored result, and it will save you extra work. Save extra work. And from the solutions of bigger problem, smaller problem, you can build on the solution of the bigger problem. Big problem solution can be built by small problem solutions. So this is what dynamic programming does. Now you may ask how I will be applying dynamic programming in this particular portion. So if you observe that exactly one difference words are considered predecessor and successor. For a word to be a predecessor of, let's say, a current word, the exact difference of their length should be 1. So it makes sense that we should sort the array according to the word length. Now you have done sorting the array with according to the word length in increasing order. Now you will be building your solution by starting with the smaller problems, smaller length words will be considered first, and on top of that we will build for the larger length words. Now when you will be having, let's say, solutions for this particular level, let's say small problem solution, your problem solutions can be obtained by this just a length length will increase by 1. If, let's say, for a particular given word we will add the contributions, check what will be the maximum contribution of its predecessors. Predecessors of a word. So for till the predecessors, what will be the maximum length chain that can be achieved? Let this be current word, and whatever will whichever predecessor, let's say P1, P2, P3, and P4. Let's say this P4 gives us the maximum length chain. So current words length of chain consisting of the current word will be 1 plus P4. So since the length of the chain will increase by 1 when you will add current word to the predecessor's chain. So that's pretty much for the logic. Now let's have a look at the implementation. Let me quickly zoom out so that you will be able to see the larger portion of the code. So first of all, you will sort the words, sort words array according to increasing order of words length. Then this hash map will be used to store the results. This hash map will be used to store the length of chains or you can say maximum length of chain ending at a particular word or say state. These particular points are called states in dynamic programming. So each word can be called a state. So what will be the max length of the chain ending at a particular word? Chain length. It will be for the word will be represented by a string and chain length will be represented by integer. So every word to consider its maximum chain length ending at that particular word. We will consider maximum contribution of the predecessors possible. Basically, those are present in words array. For each word, you will be generating its predecessors, possible predecessors. Then, if that predecessor exists in the words array, then you will consider its contribution. Accordingly, update value for current word. value of chain length for current word, and for each word you will consider a chain ending upon that word. And find maximum chain length possible. At last you will return your maximum chain length. I hope you are able to understand. Let's try to submit it once. As you can see, it's getting accepted. So the code will be available in C++ and Java both. So thank you for watching. If you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. Thank you.